Chapter 4 in class exercise 1. So this is on page number 100 and page number 26 of your handout. We will work on preliminary problems, how to calculate moment of a force in 2 dimension and in 3 dimension. So we select two example problems here, problem B and problem C. And whatever approach we apply to these two problems, you can apply the same approach to the remaining problems and solve them. Okay, so and then the next we will work on is in class exercise 1, we will work on this 3-dimension problem and we'll work on one more 2-dimension problem. So that's the plan for this video. So let's work on it. But before we do that, quick recap of how to, students often get confused about the direction of moment. So I use this approach called steering wheel approach. So whenever we need to calculate the moment about a point, imagine that point centered at the center of the steering wheel. And then the circumference of the steering wheel is tangent to the line of action of the force. So if force is applied here, extend that force and assume that the steering wheel is tangent to that line of action of the force. And this is the point of rotation. And now visualize that if you grip this steering wheel with your hand like this, and if you apply the force in this direction, what will be the direction of rotation of steering wheel? This is clearly the case of counterclockwise rotation. So this force results in counterclockwise moment or positive moment about point O. If we have another force, let's say we have force like this, okay, and we need to calculate the moment of this force about point O. What we do is imagine that it's slightly bigger steering wheel. Again, the circumference of the steering wheel is tangent to this line and the point of rotation is here, and try to visualize that if you grip the steering wheel and apply the force in this direction, it will turn the steering wheel in clockwise direction. So that results in clockwise or negative moment about point O. So let's try different examples here. What is the moment of force F about point O? You can pause the video and think about it. Okay, so fit the steering wheel center here and visualize a giant steering wheel whose circumference is tangent to this force, and when you apply the force in this direction, that results in counterclockwise moment, which is F times D, where D is the perpendicular distance from point of rotation. How about this case? Moment of this force about point A. Okay, visualize the steering wheel, okay, and apply the force about the center of the steering wheel at A. We will get the clockwise rotation. So moment of F1 about A is F1 times D. Again, assume that this is, or D1, let's call this D1. And since that's clockwise, this is negative. So we put minus sign here. For this force, let's calculate the moment of this force about this point C, and that's F3. Now, because the point of rotation is on the line of action of the force, it does not result in any moment. So moment of F3 about C is 0. Okay, so based on these concepts, we will solve problems. In class exercise 1, what is the moment of 100 Newton force about point O? You can pause the video, answer the question, and then unpause it and look at the answer. Okay, so let's work on this problem. Moment of this force about point O is nothing but force multiplied by perpendicular distance from line of action of the force to the point of rotation. And that perpendicular distance is 1 meter. Is it clockwise? So this is clockwise rotation, so that's negative. So the answer is minus 100 Newton meter. Okay, so when it's negative, it's clockwise. Or you can also write 100 Newton meter and graphic and using the arrow, you can indicate the rotation in bracket clockwise or counterclockwise. How about this 500 Newton moment about point O? Now there are two ways we can solve this. If we somehow find this perpendicular distance from point of rotation and then simply multiply by 500 with this distance, we get the clockwise moment, but it's not easy to find this distance, so we will use the other approach of dividing the force into components. So horizontal component of the force is 4/5 of 500, which is 400 newtons, and vertical component is 3/5 of 500, which is 300 newtons. And we can calculate the moment of each force about 0.0. Now this 400 Newton force actually passes through point of rotation. If you extend the line of action of the force, it passes through O. So this force does not result in any moment about O. There is only moment because of 300 Newton about O, and the perpendicular distance between them is 2 meters, and this results in clockwise rotation. If you again use our steering wheel approach, visualize the steering wheel, apply the force in the downward direction, and then the wheel turns clockwise. So moment of force about point O is 300 multiplied by 2, and it's negative, plus 0 because of this component. So that's minus 600 Newton meter, or 600 Newton meters clockwise. So when you use arrow like clockwise or counterclockwise, then always use positive number. When you don't use arrow, then use negative if it is clockwise or positive if it's counterclockwise. For Pearson mastering engineering, you don't have the option to show arrow, so always go with negative number if it is clockwise. So that is one problem. Now let's work on in-class exercise problem 4.1. In-class exercise 1, problem 4.8. Determine the moment of each of the three forces about point O. So we need to calculate what is the moment of F3 about B, what is the moment of F2 about B, and what is the moment of F1 about B. We are not calculating the total moment of these three forces. We are just calculating individual moments. Very easy to start with is this 500 Newton force, because 500 Newton actually passes through O. So moment of F3 about B is 0, because it passes through O. Now start with F2. What is moment of F2 about B? So we need to resolve the F2 into components, which is 300 cosine 60 going left and 300 sine 60 in this way. Now 300 sine 60 passes through B, so it does not have any moment about B, but 300 cosine 60 and B has perpendicular distance of 4 meters between them. So moment about B in this case is, and this force has the direction in the left side going from right to left, so its moment about point B, if you apply the steering wheel, it's counterclockwise. So it's 300 times cosine 60 times 4 meters distance between them, so it's F and this is D, so it's F multiplied by D, and that F that multiplication is 600 Newton meter. And since it is counterclockwise, this is positive. F1. You can pause the video and try to answer the question for F1 yourself. Calculate the moment of F1 about B. So resolve the F1 into components and calculate the moment of each component and add it depending on the sign, positive or negative. So here the angle is given between the vertical line and F1, and remember cosine closes the angle. So cosine component here is 250 cosine 30, and this is 250, just write it here, 250 sine 30, sine 30, yeah. Now moment of this force about B is force and perpendicular distance from B. This perpendicular distance is 3 meters, and this force about B results in counterclockwise moment. So for F1, moment about B is 250 cosine 30, that's only the force, multiplied by 3. And the other component of the force, horizontal, is 250 sine 30, and this is the line of action of that force, and the perpendicular distance is 4 meters, and moment of this force about B is clockwise this way. So that's negative. So minus 250 sine 30 multiplied by distance, which is 4 meters. So this is 149.51, or you can say 150 Newton meter. And that's the resultant answer is positive. And that's the moment of force about point B. So in each case, we have calculated moment of force about point B. Let's take one more problem from this in-class exercise, which is how to calculate moment of a force in 3 dimension. So determine the moment of the force F about point P, express the result as a Cartesian vector. Remember, moment is a vector, so in 2 dimension also it's vector. That's why we use positive or negative sign to define the direction. In 3 dimension, it's a Cartesian vector. So moment of force about point P. There is some confusion here. It should be, yeah, that's this point P is here. Okay, this point is 0, 0, 0. That is the origin. Positive x-axis is here, positive y-axis is here, and positive z-axis is going up. And this is our point P. So moment of this force about point P, MP, that's what we need to calculate. We can calculate using R cross F. Now F is fine, it's given. What is our position vector? What is the direction for the position vector? So in 3 dimension, position vector has tail always at the point of rotation. This is here, and head can be any point on the line of action of the force. So this is our position vector, and it's going from P to A. So we write this as RPA cross F. So for this case, we already know the force, 3 components of the force. We need to calculate 3 components of R. So we need to write the position vector as a 3D Cartesian vector. Okay, and for that we need the coordinates of point A and P. So we start from there. So coordinates of point A, 1, -2, 6. Coordinates of point P, 0, 4, 3. So position vector going from P to A is coordinates of A minus coordinates of P. It's always head minus tail. So it's 1 minus 0 is 1 multiplied by I. -2 minus 4 is -6j, and at 6 minus 3, 3k, and this is in meters. And we have been given F as -6i plus 4j plus 8k, and this is given in kilonewtons. So our final moment will be kilonewton meter. And for this we use the matrix determinant. So moment of F about point P, MP is RAP cross F. So first three first row is always ijk when the moment of a force is about a point. Middle one are the 3 values for the components of R. So those are 1, -6, and 3. So 1, -6, and 3. And the last one is 3 values for F. So -6, 4, and 8. Okay, and when you apply the matrix determinant solution, that is for the first part it's I, and now it's product of 6 minus 6 multiplied by 8, then negative sign, and then this multiplication 3 times 4. Middle part is minus j. Now this negative sign is part of equation, and then it's 1 multiplied by 8 minus 3 multiplied by -6 plus third part is k. So we leave that. Oh, sorry, this should be k. ijk, and then it's 1 multiplied by 4 minus 6 multiplied by minus 6. And when we solve all these components, so the first part is minus 60 I, middle part is minus 26 j, and third is minus 32 k. And that's our moment as a 3D Cartesian vector in kilonewton meter units. Moment of a force about pi p. If you like, you can actually calculate the magnitude of this moment by square root of this 3 component square. I leave up to you to calculate this. Thank you.